Hi
Hi,
everyone. Want to introduce yourself?
my name's William.
Yeah, this is my son William. He's gonna be helping me with our demo in just a few minutes. Um, yeah, while we're waiting, if you have any questions, feel free to use the chat. Um, we're gonna get started in just a few minutes. This will just go till 10:25, 10:30 or so. We'll be
We're
back
not
to
really
regular
sure.
lectures on Thursday.
So,
All right, we'll give people a few more minutes. Let me double check this is all streaming, right? Okay, I think so.
yep, all streaming.
Mm-hmm.
Why is this sideways on now?
Yeah, that's showing us people signing on. There's a little microphone counter there. All right, we'll give people another couple minutes. They want to get online. What have you been up to, Will? Since you've been home from school, what kind of stuff have you been doing at home?
Well, we were just playing downstairs. So, I'm trying to build a little fort on the couch so that we don't have to rebuild the fort every day. Can you help me with that when you're done?
Help build a fort? Sure.
Yeah,
We can do
over
that
on the
later today.
couch.
Mhm.
I was trying to build a fort that we don't use the couch cushions, but it's on the couch so that we don't have to take apart the couch.
That's a good point. They don't
Yeah.
have to take apart every day.
Yeah, just do it. We don't have to take apart the couch.
Yeah. Okay. Well, everyone, we're going to get started in just a few minutes. This is my son William. He'll be helping us with the demo in just a few minutes. Yeah, this is just a short check-in to say hi to everybody. If you have any questions about all the changes to the class, feel free to use the chat. We'll be back with a regular lecture and lab on Thursday.
Oh,
Yeah.
hi, William.
Yep.
Hello to both of you.
Yeah.
Hi. Hello. Hi. Good morning. Good morning. Hi, William.
Yeah.
That's
Nice
a lot of chats. Chats. The chats.
The chats.
Chatting.
All right, I think we're gonna go ahead and get started. So I just wanted to spend a few minutes today just refreshing your memory about stuff we were working on before the break. So we're just gonna do a short experiment and try to use a t-test to answer a question that William wanted to answer, which is what?
We are going to test both of these cores, which we practiced with both of them. This one got higher.
Well, we'll see what happens in this one.
We're not really sure.
Yeah.
I thought this one weighed more, but this one goes faster. I don't get it.
Yeah, we're gonna see which of those cars can go farther on the track, right? To see, right? We're gonna test and
I
what's.
guess the opposite. I don't get it.
So what's your hypothesis, Will? Your hypothesis is that white is going to go farther?
Yeah, from the last time. It's hard to move this because once I moved it the right way, it's the opposite way.
I know it's tricky. You got to hold it in front of the camera there. See, there you go. Yeah, not that close. There you go. All right. So what's your hypothesis, Will? The white car?
Yeah, the white car. This is how it was. Oh,
Okay.
green car on the loose.
All right. So we have our extremely scientific track set up here. So William is going to be in charge of the cars. I'll be in charge of recording how far they go. We're going to do 5 trials of each, and then we'll try to do some statistics.
Yep.
All right?
We're going with the white car.
All right. Car number 1 is a white car. We're going to go first. Stick that flag down. All right. Trial 1. Here we go. All right. Good. Ended up about, let's see, 17 and... I'll say 5/16. 17. All right, so grab that white one. We're gonna do trial number 2.
Flag down.
Yep. Oh, yeah, there you go. All right, a little farther that time. We got 19 and about an eighth.
Eighth of a 19th. Okay, 4th time after white car.
All right, 3rd time. Yep. White card number 3. So push it up against the flag. There we go.
And go.
All right. Oh, that was a short one. All right, that's only about 16 and an eighth.
And up to the 4th. 4th one, I think.
Yep.
And up.
All right. Whoa, that was a big one. About 20 inches on that one. All right, let's do one more with white car.
And so we're just seeing which one goes total.
Yep. All right. Looks like about 18 3/4.
And now we're going on to the green core.
All right.
This
Car number
guy
2.
is dismissed. Dismissed. So, green core. Let's see what you got, green core. Weird
Ooh.
noise.
All right, about 17 1/4.
Almost up to 20 inches. Second time for the green core. Let's go.
All right, it's about 16 I'll say 1/16.
1/16.
Yeah, 16 1/16.
Now, onto second time. Third time, I think? Yeah, third time.
All right. So that one's only, let's see, 15 1, 2, 3, 4, 5, about like 5/16.
Now, fourth one.
Yep. All right. That looks like 14 7/8.
Okay, last one for the green core.
Yep.
If this one gets over 20 inches, this green core will win it.
Let's see.
And up.
All right, that's about 16 1/8. All right,
And
well,
so the white core was better. I think it's because the weight.
maybe. Yeah, so we'll see. So the white card definitely did better on average. So what my class and I we'll do is we'll try to see if how sure we are that the white card is better. Okay?
Up.
All right, well, I'm do a few things with my class now, all right? Thank you for your help.
Bye.
All right, bye. Okay. Thank you very much for your help. All right, why don't you hang out downstairs? I'll be down there in a few minutes, okay?
Okay.
All right. Okie doke. So, so we have our data, and as William summarized there, right on average, looks like car 1 was doing better than car 2, but not. But maybe not by that much, right? And the question is, how sure are we, just based on these 5 trials of each, are we really confident that car 1 is better than car 2, right? And so this is a good candidate for running a t-test, right? These are mostly independent scale measurements that we're getting. Remember that the there's sort of 3 different types of t-tests, and so the kind that we're interested in here is that unpaired 2-sample t-test, right? We're measuring from 2 different populations here. One is the car times for the white car, one is the car times for the green car. So we can use R here to run this this kind of unpaired 2-sample t-test. So we haven't actually talked too much in the class about how to actually load in data into R, but R has these import options here. So we're going to do an import from Excel. And yep, that should work. Let's see, I'm zoomed in maybe a little bit too far here. One sec. Okay, so all right, so we've got our data set into R now. You can see for each of these measurements, we're labeling which car we got the measurement from and its distance. So so there's a bunch of things we can do. One thing that we usually like to do with any kind of data is to visualize it. And so here, one thing we could do is to use our GF histogram. What we'd like to do is plot distance. So we could just do this, which is just plotting all of our distance measurements. So we can see, right, they range from about 15 to 20. But this is just combining across both cars. We really probably want to do something more like distance grouped by car, for example. Right, now we have two little plots here. We don't really have enough points to do sort of a real histogram. These are all just bins of size 1, but right, you can see that that the first car here is tends to be a little bit higher, and also maybe has a little bit more variability than the second car. So we'll come back to that point in a little while. So so the way to do this t-test sort of by hand, right, is to think about computing our t-statistic. And just as a reminder, right, our t-statistic is always going to look like something about, in this two population case, our t-statistic is going to be something like the difference in the means divided by the standard error of that difference under the null hypothesis. So the difference of the means here is pretty easy to compute. We could do, we could use our diff mean function, for example. Right, what this tells us is that on average, car number 2 is going about 2 1/3 inches shorter distance than car 1. And right, so this is just telling us something about our sample, that in this particular sample, the car 2 was going about 2 inches shorter. But what we really need to know is something about what the standard error of our sampling mean is here. Right, so we got this difference of -2 in this particular data set. The question is that impressive or not? Would we expect, is it possible, even if the null hypothesis is true, is it possible to get a difference this large? So we need to get a t-statistic, we need to know what the denominator is here. We need to know what the standard error of the mean is, the standard error of the difference in the means in this case. And as we talked about last time, there's a bunch of ways of calculating this depending on what kind of assumptions you want to make. The simplest way to do this is that if you have the same number of observations in both data sets, which we do, and if we just make the assumption that the population variance is the same in both of these data sets, which may or may not be a good idea, we'll just assume that it is for now, then this standard error is pretty easy to compute. All we need to do is just take the variance within each of our populations. So we can just take the same line of code here, but instead of calling diff mean, we're going to do variance of this. Right, so this gives us the sample variance in each of these groups. And all we need to do is add those two variances together. And then divide by the number of data samples in each group, which is 4 here. This gives us the pooled variance. And so then all we need to do is take the square root to get this back into standard deviation units. So this tells us our standard error is about 0.9 here, again, making this assumption that the variances are the same in these two populations. So then to get our t-statistic, all we need to do is take the difference in the means, which is this 2.3357, and divide by this pooled standard error. Right, so we have a t of 2.61. And again, the question is that big or small? In order to figure that out, we'd have to use a t distribution. And so remember, there's actually lots of t distributions, and which one we use depends on the degrees of freedom of that distribution, which in this case is just, well, actually in the two sample case, the number of degrees of freedom is the total size of the data set minus 2, right? So that's the number, it's the sort of degrees of freedom of each group, right? Which is the size of each group minus 1. We add that together, we get the total size of the data set minus 2, which is 8 in this case. So we could work this out with the distribution. I'm just going to cheat and just use the t-test in R to do this. There's a few ways to write this. This is the way it's most consistent with what we've been doing, right? So we're doing a t-test on distance. We want to group them. The two groups are going to be defined by the car label. There is also an argument here about whether we want to assume that the variances are equal or not. For now, let's just set that to true. So what we can see here is that, so first of all, let's see, did we get the right t-statistic? Almost, maybe up to some rounding errors there. So our t-statistic is 2.93. The degrees of freedom are 8 here, which again is the total size of the data set minus 2. And this gives us a two-tailed p-value of 0.019, right? So what that tells us is that the chance of getting a difference between the groups this large in the null distribution is relatively small, right? The chance of in the sum of the areas in both of the tails here that are beyond 2.926 is relatively small, right? And so we could reject the null hypothesis. Now, right, the one assumption we made here, which is maybe not so great, is this variance equal assumption. And so, right, you can see just looking at the data, it seems like this maybe is not true. Like CAR2 seems a little more consistent than CAR1 was. So if we change this assumption here, our t-statistic doesn't change that much. It's using a different formula, but it's going to come out basically the same in this case. The degrees of freedom do change, and you can see they're now like a weird non-integer thing. And our p-value goes up a little bit. That's usually going to be the case anytime we relax assumptions in our model. Usually p-values are going to tend to increase. It basically just means there's more, because we don't have this assumption anymore, it means we're more uncertain about how the world works. And so we're less sure that the null hypothesis couldn't have generated this data. But even in this case, right, we would still reject the mean in this case. You can see it also gives us a 95% confidence interval. So remember the way that we could compute this is that we would take the measured difference between these two populations, and then we would go out some number of standard errors away from that. And the number of standard errors we go out depends on the critical t-value here, which also depends on the degrees of freedom. Right, so what this tells us is we're quite sure that CAR1 is faster. It's going farther, and it's going somewhere. If we actually had an infinite number of measurements here, we'd expect that it's going to go farther by somewhere between 0.4 and 4.25 inches, right? So we're pretty sure it's better. We don't know exactly how much better it is. It might be only a little bit better, or maybe it's a lot better. We would need a lot more measurements to really know, but we're quite confident that it's better. Okay, so I just wanted to show sort of a complete walkthrough of how we'd actually use a t-test here for a real experiment. We'll do a brief review of everything on Thursday too before we start new material. Let's see if there are any other questions in chat. Yeah, just to clarify about the degrees of freedom there, right? I'm using a formula. This is from like the middle of the t-test, slide 29 from the t-test lecture last time, that for this particular kind of test where we're assuming equal variances and we're doing this 2-sample unpaired populations test, we just take the number in one group plus the number in the second group minus 2. Okay. All right. Any last questions before I log off for today? Feel free to also send me an email. Office hours are proceeding normally this week, so I'll also be on my office hours tomorrow. I'll be starting up the live stream for class on Thursday, the regular time. Please join us if you can. Otherwise, feel free to watch it later and email in questions later on. All right, I guess I'll turn it off for today. We'll see everyone soon.